My name is Michael Barris. I'm a Principal Database Solutions Architect. I'm with the Amazon Relational Database Service. I'm also going to be joined a little bit later by Manish Mohite, who's the head of cloud engineering for our customer Jeffries. I always like to talk about what our services can do, but I think you get the most from hearing from one of our customers directly about what they've experienced with the service. Just a little bit about myself. I've been with Amazon for just about 13 years now. 7 years with the relational database service, mostly as a database engineer, helping the team that designs and builds RDS. The last couple of years, I've been working on our product management team, where I help guide the roadmap and talk to customers and help them understand what RDS can do for them and help us understand what RDS needs to do for them. We're going to talk about new features for Amazon RDS for Oracle, Amazon RDS Custom for Oracle, which is the new deployment model we launched last year, as well as, since we have two services now, how to choose between those two for your workloads. And then again, we're going to hear from Jeffries at the end of it. Now, this is a sort of a 300-level session. So I'm going to assume that you all know Oracle Database pretty well. I assume you know RDS pretty well, but I'll go over that a little bit. And then we'll keep it pretty low level. So let's dive in. One other thing that's going on in this room that we're piloting is a live polling process that we're going to be introducing for reInvent. And so if you could do me a favor and take your phones and either check this QR code, or you can use the AWS Events mobile app. And in the bottom right, the dots, you'll get a more, and you can choose live polling and enter this number. This is just a sample poll to kind of show you how the process works, and we can figure it out. I'm going to have two other polls during the talk, and we'll kind of get some information from you about the audience and how you're using RDS and AWS today, and just kind of some useful tidbits for us to understand who we are. So if you've got the QR code, let's see if we can get the results back. Alrighty. So we got some first-timers here. That's great to see. This is my 6th reInvent, I believe, counting the virtual year. But it's nice to see some fresh faces here. It's nice to see some familiar faces here as well. All right, so with that behind us, we'll have two more polls, and I'll let you know when those are coming, and we'll see how those go. So I want to start with just a quick refresher on what is Amazon RDS. The Relational Database Service is a managed database service for relational databases, where we essentially use automation to provision, deploy, and manage and maintain database instances for you, so you don't have to do that work. There's in deploying and managing your applications, there's a lot of work that you have to do with your schemas, your security, your users, lifecycle management of everything else involved. And so having to deal with all the infrastructure work that's time-consuming and error-prone and really doesn't differentiate you from your competitors seems like an unnecessary task, and that's why we built RDS. And so we support 6 database engines. So we have our open source database engines like MySQL, MariaDB, Postgres. We have our commercial engines, Oracle and Microsoft SQL Server, and of course we're here to talk about Oracle. And then we also have Amazon Aurora, which is our custom-built cloud-based platform, where we've essentially taken the open source engines MySQL and Postgres and built cloud-native storage underneath them, keeping the SQL engines on top so that all of your applications are fully compatible, but the storage is cloud native and 6-way replicated and has a lot of great capabilities. Now, this managed service gives you all these great capabilities because we have automation that's doing these things. We can quickly provision, we can be secure, we can provide availability and durability via features like multi-AZ and replicas and backups. And we can enable your security and compliance requirements. And to me, what it all comes down to is this number at the bottom. This comes from an IDC survey. 39% lower database total cost of operations for RDS customers compared to on-premises customers. The same survey says 86% faster to provision new databases when you use RDS compared to on-premises. And the one that really gets me is RDS customers experience 97% less unplanned downtime than on-premises customers. So in a nutshell, that's what the service provides you. Lower TCO, easier management that lets you focus on the things that matter for your applications. Now, as a DBA, I kind of like to think about the service in terms of how it connects to other services and how it's organized. And since we're going to be talking about RDS for Oracle and RDS Custom for Oracle, I just want to kind of differentiate these two so we have sort of the mental model of how these work. So with the relational database service, when you create an instance, all of that lives within the service. We create an instance for you, and on that, you have your database files, database storage, operating system configuration. And of course, that's built on foundational AWS services like Amazon EC2, Amazon Elastic Block Store, Amazon S3, and then as we'll talk about in a moment, Amazon EFS now in the mix. What that appears like in your account is in Amazon, the RDS instance appears in the RDS console, and you'll also see an elastic network interface, and that's essentially how we plumb your account into the RDS service. But you don't see the underlying resources, you don't have access to the host, you don't have to worry about the storage configuration, we've already managed that for you. And this endpoint is how your applications connect to the database via the listener. So you don't have host access, but you have access through the database listener. And of course, part of the service, we're able to offer additional capabilities like multi-AZ, which provides synchronous storage replication with a 99.95% uptime SLA, as well as read replicas or mounted replicas, which we'll be talking about in a moment. Now, if we contrast that with the RDS Custom for Oracle service, what essentially lives in our service for RDS Custom is the automation. So that our control plane components are in the service, but then everything is actually in your account that gets created. So the RDS instance is in your account, in your VPC. The Amazon EC2 instances, the S3 buckets, the EBS volumes, all of those are visible to you. You have direct access to them. And so it's a slightly different deployment model. And of course, you still see the RDS Oracle endpoint. It's going to still be an ENI in there. But the benefit here is that this allows you, we can still see these components. You have the ability to SSH to EC2 hosts. You have the ability to make some modifications and customizations and changes to that to satisfy the requirements of some of your perhaps legacy and packaged applications. And what really makes this work is what we call the support perimeter. So you do have the ability to make changes to your infrastructure, but we also will make sure that those changes aren't things that break us. And so if you've made a change that prevents us from keeping our service goals to you and our promises, then we'll take you outside of the support perimeter, send you a notification letting you know that part of our automation is no longer managing your database, and you need to do something to get back into that support perimeter. And I'm not going to go too deep into that part because that's what Manish is going to be talking about with Jeffries' experience with RDS Custom for Oracle and how they've been able to use those capabilities and why that's been important to them in their journey with the cloud. And of course, with RDS Custom for Oracle, we do have replicas as well as part of our managed service. A little bit unique for RDS, we also have the ability to create customer-managed replicas. So you do have access to the operating system. You can edit TNS files. You can edit networking configurations. You have sysdba access. And that means that now you can configure your own data guard configurations, either hybrid back to on-premises. You can control the configuration more fine-tuned fashion for your RDS Custom for Oracle replicas. But you get a little bit more flexibility here. So that brings us to our first poll. So if you could whip those phones back out, and either, again, check this QR code with your camera or in the AWS Events app, enter this code in the live polling section under More. So I'm just kind of curious, what's best describes your experience as an organization with running Oracle databases on AWS today? Are you just getting started? Are you starting to self-manage on EC2? Are you mostly on RDS Oracle? Or are you already modernizing most of your workloads away from Oracle like we hear a lot of customers do? So I see phones are down, so let's see if we've got some results here. Alrighty, so an interesting mix. So we've got a lot of people are already running Oracle on EC2, so perhaps you're not familiar with RDS yet or it doesn't satisfy your requirements. So perhaps RDS Custom for Oracle may be useful for you in those cases. And it sounds like we also have a lot of people that are just getting started. So really great to see. We've got a lot of customers in different places in their journeys. But there's always someone new, getting started. And so glad to see you're here today, learning about RDS Oracle if you're, new to AWS. Alrighty. So let's dive into some new features that have been launched in the last year that I think are interesting for you to know about. Let's first talk about database versions. When you want to run an Oracle database, the very first step is you've got to decide what version you want to run. You've got to get software, install software, figure out how Oracle Universal Installer works, figure out how Oracle Universal Installer changed since the last time you ran it, and get those components working. You have to figure out what patches you want. There's a lot of work that goes into that. And with RDS Oracle, you simply just choose a version from a drop-down. Our database engineering team has already done all that work for you of figuring out versions, how to install them, how to secure them, how to manage them. That does mean that we only support the versions of Oracle database that Oracle is providing support for. So one of the things that's a little bit tricky about RDS is that when Oracle stops providing patches, we require you to move to the newer versions that they are providing patches for. So today we support 19C, and we added support earlier this year for 21C. So 19C, 21C. 19C is the long-term support release. It's going to be, we can see the dates here. All of these dates are they're published well in advance, many years in advance. We go by Oracle support, what the dates they show in this note. If they change those, we'll keep our deprecation plans in line with those. But you'll see this year we deprecated versions 12.201, 12.102, so RDS customers can no longer run those versions. And keep in mind those future dates. So 19C is coming end of support in 2024 for customers that have Premier support. Oracle's already announced that extended support for the first year, as long as you have Premier support, that's going to be continued through 2025. They may change that, but that's what the dates look like today. And then for extended support customers, which is going to be license included customers, or bring your own license customers who've purchased that extended support from Oracle, that's available through 2027. So generally, most customers are going to be in 19C today. Again, that's the long-term support release. Available through 2027. 21C is an interesting innovation release, but it does have a much shorter support timeline. And of course, for minor versions, we come out with a new minor version each quarter based on the release update, and this will include Oracle's patches as well as a few custom patches that are covered in our documentation. Similar to the database, there's other components that we can optionally install on the server for you via what we call option groups. And a couple of good examples of these are Oracle Enterprise Manager Cloud Control Agent and Oracle Application Express. These are kind of interesting because they sort of work in a shared responsibility model where in both cases, we'll install these on the database instance for you, and it needs to connect to a component that you manage. So in the case of cloud control, you're still going to manage your Oracle management server, whether that's on EC2 or on premises, managing your other Oracle databases, and we'll install the agent and connect it to that OMS as long as there's a network path. So we, again, handle those versions. We do the figuring out of how to manage those and upgrade them. We support up to 13.4 and 13.5 today. And then similarly with Oracle Application Express, we've added support for 21.1, 21.2, and 22.1 this year. We have a lot of customers that run AppX, so we do try and keep those up to date as those new product versions come out from Oracle. And again, this is going to be a case where we'll install the schemas for you since that requires SysDBA, but it needs to connect to AppX listeners that you have running on your own EC2 instances. Now, instance types are kind of the same as versions. So, we've got our version figured out. We've got the Oracle software. It's already taken care of. But if you're running on premises or if you're running self-managed, you've still got a lot of work to do configuring servers. You've got to figure out what EC2 instance types you want to run. You've got to figure out which version of the operating system you want to run, what patch level, kernel parameters, performance configurations. And as EC2 generations change over time, maybe I need to change how I manage my EBS volumes. There's a lot to keep up with there. And again, our database engineering team just does this work for you. So you just select from a dropdown the instance type that you want. That means that all you have to worry about is your choice of instance type, which generally you're going to, the three factors that I think you should generally look at are vCPU, memory, and storage bandwidth. Storage bandwidth is often overlooked. Each EC2 instance type can only create so much read and write throughput to Amazon EBS volumes. And so you need to make sure that all three of those are tuned. And of course, because Oracle is commercially licensed database software, you want to minimize those vCPUs to the number that you need. And generally speaking, you want to minimize the size of the instance to the workload that you need, because you can change it pretty readily. It's not like on premises where I've got a piece of hardware that I need to amortize over 5 years and make the best of it over time. I can readily change these EC2 instances by just making a modification, and for multi-AZ customers, that's just going to be a quick failover. Now, I'm not going to go through the full list of instance types that we support, but we have launched quite a few new instance types this year. Some of them are actually coming out in a couple of weeks. But in a broad sense, we support three major families. There's the burstable, there's the general purpose, which is just kind of a good blend of memory and vCPUs. And then a lot of customers run Oracle database workloads on our high memory instances. So these have more memory per each CPU, depending on the instance configurations. Three things that I think are useful for you to know. First of all, we're starting to see a lot more letters in these instance names. So we're now seeing I show up in our M6I and our R6I families. These have always been there. It's just historically, EC2 has always run on Intel hosts, but now we have AMD hosts. And of course, we have our ARM-based Graviton hosts. Oracle still only runs on Intel, so the I just means that these are Intel boxes. We've also launched D variants this year. This is for local disk storage. And where this comes in handy is you can put temporary table spaces and database smart flash cache now on the local NVMe storage that's physically attached to the server. So you lose the latency of network attached storage with EBS. You get very high throughput and very high IOPS with these. So these are going to be helpful if you have a workload that is bottlenecked on temporary table spaces. They'll work faster on this. Or bottlenecked on perhaps buffer cache. If you don't have enough memory and maybe don't want to go to the larger instance class to get more memory, perhaps a D variant can allow you to have essentially an L2 buffer cache on those local drives. And the third one, upcoming in a few weeks, we'll be launching the X2 instance types. These replace our X1s as well as our Z1Ds. These are for larger workloads, but it's important to know that these are available. These support up to 4 terabytes of RAM and 128 vCPUs, so these are big, beefy boxes. And we have a few different variants. Again, there's a lot of letters here to keep track of, but the IDN, the X2 IDN, those have up to 2 terabytes of RAM. The X2 IEDN, the E is for extra memory, so those have twice the memory per vCPU. That gives you up to 32 gigabytes per vCPU, which is a pretty great amount of memory for keeping those vCPU counts down. And then the X2 IEZN, the Z is for high frequency turbo CPUs, and so these are Intel all-turbo CPUs running at 4.5 gigahertz. And that can, again, for some workloads, allow you to reduce the vCPU count by using fewer, faster vCPUs. A couple other things that we've worked on this year. So on the networking side, we now support IPv6. So for customers that, if you've got IPv6 elsewhere in your workloads and these databases need to be able to communicate with that, that's going to be great for that. Simply, all you have to do here is make sure that all of the subnet groups all of the subnets in your subnet group are enabled for IPv6 in your VPC. And then when you move an RDS Oracle instance into that, you'll have an IPv6 address. Now it is dual stack, so you'll have 4 and 6. But if you do have IPv6 requirements, you can start working with those now. And then in the SQLnet configuration, we usually manage the SQLnet configuration fully for you. We do give you a few parameters that you can modify by enabling things like secure sockets layer, transport layer security, TLS, or Oracle's native network encryption. There's a handful of parameters that you can use to configure those. 2 that we've added are allow weak crypto, which is the name for it seems a little bit confusing. We don't want to allow weak crypto. That's the default. But now we allow you to set that to false if you want. So you can not allow weak crypto. And what that allows you to do is, when you're configuring these, you get a whole just list of algorithms to choose from, and it's hard to remember which ones I should and shouldn't use. And so by setting this parameter, it's basically going to turn off any of those parameters that Oracle considers outdated and weak. So, the MD5s and some of the older encryption algorithms. And we've also allowed you to set the remote listener database parameter. We don't support Oracle with RDS proxy today, but a lot of customers want to use Oracle Connection Manager, or CMAN, as long as you're using Oracle Database Enterprise Edition, which can function as a proxy and can do things like SSL termination and protocol switching, static IP address management. So that's Oracle's software for that. You'd still, again, run that on your own EC2 instance, but if you do want to use that, now you have the ability to set remote listener to connect those two. Now let's talk about data migration real quick. When you moved, so you've got your source databases, you've got a target RDS Oracle instance you want to move data to. Maybe that might be from on-premises, it might be from another RDS Oracle instance. And you have some way of moving data back between these two. So you've got either database links or just your network connectivity from on-premises. And today we support logical export and import. So that means you need to pull data out of your database, store it in some kind of canonical format, and then load it back into the database. And so that's going to be things like, it could be as simple as SQL or SQL Loader to do that. And it can be log mining-based tools like Golden Gate and SharePlex and Stream and others, and our own database migration service. And then for the bulk loads, data pump is usually what you're going to do with that. There's a couple, and then of course, the way you do this is you can either move these across database links or the network. But what a lot of customers do is you do your data pump exports to local storage where the source database is. We support Amazon S3 integration, so you'll copy those files to S3, and then copy those to your RDS Oracle instance, and then load them into your database. Now, there's 2 challenges with this approach. One, there's a lot of steps here. You have to dump, and then move, and then load. And so there's copying of files. They can take time and contribute to the amount of time that this whole process takes, because sometimes this might have to occur during an outage window. And the second issue is that these dump files take up space. So in some cases, let's say you have a 1 terabyte dump file you need to load into your instance. You might need to create a 2 terabyte instance, stage that 1 terabyte dump file, load it into a terabyte of table spaces, drop that 1 terabyte dump file, and now I've got a terabyte of space that I can't reuse. And change that for whatever your size is. When you get to larger sizes, that can really add up, and you're paying for that storage that you might grow into over time, but you're paying for it starting today. And so what we've added support for just recently is Amazon Elastic File System, or Amazon EFS. This is NFS-based storage that you probably are already using on a lot of your other systems, on your Amazon EC2 instances to share files back and forth. And so now with EFS, you can just use data pump. You mount that volume directly to an RDS Oracle instance and your source instance, dump directly to it, read directly from it, and you don't have to worry about the space that's used up by those dump files. And so, just kind of a high-level overview of this. You can attach this to your EC2 instances, your RDS Oracle instances. You can do it just for today if you want to do a quick migration. You can keep it on there forever if you want to build that as part of your application where you're maybe shuttling files or output from applications to databases. It allows for easy sharing of data between application servers and databases. And of course, EFS itself is petabyte scale. You don't have to choose a size. You just start storing data in it, and it's going to grow to suit your needs. There's a few different ways that you can configure it for performance, but overall, it's designed for 4 nines of availability and 11 nines of durability, which is a pretty astonishing amount of durability. And finally, let me talk about replicas with RDS Oracle. So we've had replicas for a few years. We came out with in-region replicas first, cross-region replicas after that. We support replicas in a variety of ways, and what these really are, we call them replicas. These are Oracle Data Guard standby databases or Oracle Active Data Guard standby databases if you want to run them in read-only mode. And of course, that requires having both Enterprise Edition licenses, and if you want to run them in read-only mode, you'll need those Active Data Guard licenses. But otherwise, this is a fully managed Data Guard implementation by RDS Oracle. You can have up to 5 total replicas per source instance, and they can be in the same region or different regions than the source instance. Now, we've supported promotion historically, and this is the way we do disaster recovery today with RDS Oracle, where in this example, I've got a replica in another region. This could be in the same region, of course. And when you promote a replica, what we do is we terminate replication. We convert the standby to a standalone primary instance, and then open it for read-write access, and now your applications can reconnect to it. Now, the challenge here, first of all, is we're going to take a full backup of this, because we don't have backup supported for replicas. And that means the first thing that's going to happen after this is we want you to get back to durability. And you may not be able to make certain API calls until this backup finishes. And that can take quite a few hours for very large instances. The other thing is that this is now its own standalone instance. It has been open reset logs. It is broken off from the original primary instance and any of its replicas. So it now can't get back into replication with those. So if you do a replica promotion for perhaps a DR situation, what you'll need to do is recreate replicas for this instance that will allow you to go back in the other direction. So there's a little bit of heavy lifting to do there. And again, these can be in the same region or a different region. And so a couple of things that we've launched this year is automated backups for replicas, first of all. And that means that you can have those backups running on a daily basis on your replicas, or at least one replica that you might want to use for failover purposes. We'll need the backups there. And so what that allows you to do is you do that promotion or a switchover, and that next backup that you take right afterwards is going to be a fast incremental backup. So we'll still have to take a backup. It'll still be in backup state for a little while, but should be a much shorter time period. And the other thing we've launched is Replica switchover. So you now have the ability to invoke a data guard switchover of your Replica instances. So in this case, again, we're using a cross-region example. It could be the same region as well, though. And so we've got a primary and one of its replicas running in region 1. We've got another replica running in region 2. And then when we call a switchover just via an API, we're going to terminate those application sessions, which might start rollbacks on the primary. We're going to convert it to a standby database. We're going to convert the standby to a primary, resume replication, and we're going to send the replication back to the existing instances. So now this is still related to those original instances, and this allows your application to reconnect to the promoted replica. So now you've got a primary. I've still got my original instances. They're now replicas, and I've just switched the direction of replication. And what this is really great for is that DR testing that you need to do and hopefully are doing to keep your runbooks up to date. So now I can switch to my other region. I don't have to recreate replicas. I don't lose any data. It's a RPO0 operation because it's a cooperative operation between the primary and the replica. And I can switch to from my source region to my DR region. And then, of course, I can switch back to my source region, again, with a brief outage, but no having to recreate replicas. So we're really excited about that capability. Now we have 2 capabilities here, so which one should I use for which case? So promotion is still going to be for our disaster recovery. So switchover is a cooperative action between a primary and a replica. So if I've lost access to my primary, I can't do a switchover. And so you're still going to use promotion for disaster recovery today until we support failover. And you're going to use these for things like seeding dev test environments, seeding logical replication environments, and perhaps creating new primaries. But for switchover, again, those readiness drills for your DR runbooks, and shifting traffic regionally. So an interesting case that we've heard from some customers is they might run, for example, their production database during US business hours in the US, And around the world, they have a replica running in Asia. And then as the business hours reach a certain point, they do a switchover so that the local primary database is local to the kind of a follow the sun approach. So there's a few different ways that you can use this, but now it's just an additional capability that we have there. Alrighty, so let's get to RDS Custom for Oracle new features. So that was RDS Oracle. That's our fully managed database service. Again, RDS Custom for Oracle lives in your account. You have access to the hosts. You get a little bit more flexibility. I think it's kind of useful to think of it in this model. When you think about the activities that you have to do to run these databases, when you're running on premises, you've got everything from the dirt all the way up to the application that you have to worry about. So the racking and stacking and powering and networking, configuring your operating systems, all the work that you're used to doing on premises. And so going to EC2 is already a big step up from that because we're managing infrastructure for you. You don't have to buy servers. You don't have to worry about life cycling them. We manage the server and essentially the operating system. But still, everything on top of that, all the way up to the application, is something that you have to take care of yourself. And so that's where RDS has been really great for customers because we do a lot of this work for you on the infrastructure side, like I mentioned at the beginning. So your OS configuration and patching and your backups and your high availability, all of that's just fully managed by the service or a configuration option with the service. But we talk to a lot of customers that can't quite run their workloads in RDS Oracle, either because they don't have host access or they don't have sysdba access with the service, or it's in some other way too restrictive for what they need for their applications. And so that's where we've launched RDS Custom for Oracle to sort of fit between the two of these. So it's not as unmanaged as EC2. It's not as fully managed as RDS. And you'll see in the middle here with these boxes that we've got a shared responsibility model for some of these. So some of these components we kind of work together on. For example, high availability and backups and scaling. There's actions that we take. There's actions that you take. And again, on the sort of the operating system side, I think that's where we'll hear some interesting information from Manish on how Jeffries is using that to install agents and manage their infrastructure. Now, with RDS Custom for Oracle, we don't have the same deprecation requirements, so you can largely run whichever version you want for as long as you want. We do have to build automation that can talk to those versions. So we originally launched with 19C, and now we've backported as far as 18C, 12.201, and 12.102, largely to support some e-business use cases with those older versions. And again, the versions are fully up to you. So now you get we use custom engine versions where it's a bring your own media model where you'll upload your installers and patches. We'll create a version for you, and then you'll just use that as the version you want. When you want a newer version with a newer release update, just create a new custom engine version and tell us to use that, and we'll upgrade you to that. Now, one new thing we've launched for RDS Custom for Oracle this year is multi-tenant support. So container databases are now supported with RDS Custom for Oracle. When you create an instance, or actually when you create your custom engine versions, now you'll specify a different engine name, the custom Oracle EECDB engine. And when you create your instance, you'll use a CEV based on that. When you create the instance, we're going to create a container database called RDS CDB. It's always going to be called RDS CDB. And that's created and partially managed by RDS. And then we're also going to create the first pluggable database based on whatever you've passed in the DB name parameter. So that's by default ORCL, like it's always been, or you can specify whatever you want from that. And then from there, the additional pluggable databases are fully managed by you. So you create pluggable databases, you drop pluggable databases, you migrate them, unplug and plug from other instances. That's fully managed by you with RDS Custom for Oracle. We leave that up to you, so you can worry about that. Now, of course, keep in mind the multi-tenant is a licensed option from Oracle. So if you're running Enterprise Edition, you could purchase the licenses for that for multi-tenant. Oracle does support up to 3 pluggable databases without the multi-tenant option, but you'll want to make sure that you have your licensing checked out before you go creating pluggable databases. And of course, while you can create those pluggable databases, underneath all of this is still our RDS Custom for Oracle automation that's keeping your databases up and running. If we find databases that have crashed or closed, we'll reopen them and keep everything nice and healthy. Now, for RDS Custom for Oracle replicas, very similar to RDS for Oracle replicas with a couple of notable differences. Again, these are fully managed data guard or active data guards, physical standby databases, depending on what you've chosen. And again, active data guard does require additional licensing. By default, all of our replicas run in asynchronous, so maximum performance mode. But with custom, because you have access to the host, now you can put these in max availability mode or max protection mode, or you can even connect your own fast start failover observer to these. Now, one restriction is that these are up to 5 managed replicas in the same region. So today we don't support cross-region managed replicas with RDS Custom for Oracle. But again, you can create your own your self-managed replicas on Amazon EC2 or even back to on-premises. So we do have some customers that are using hybrid data guard configurations with on-premises databases and physical standby databases in custom. And so this year, we've also launched the ability to do promotion, which has previously been supported in RDS for Oracle. Now we support Replica promotion for RDS Custom for Oracle, and it works in essentially the same way. So we'll make that promote read replica API call, we'll terminate replication, we'll convert it to a standby primary standalone database, and then we'll allow your read-write applications to connect to it. And of course, we'll take backups, but we already support backups on both primary and replica instances in custom. Switchover and failover are kind of interesting with custom. So they're also supported, but we don't have an API for it. So this is something that you'll do yourself, customer managed via DGM, GRL, or again, you can connect your own fast start failover observer to this. And what will happen is you'll initiate that switchover or a failover process, and as long as they're managed replicas, RDS Custom will detect that role change and update that in our control plane so you know which one's a primary instance and a replica instance. So again, we do support switchover and failover with custom, but that's going to be an action that you'll take manually either via the data guard broker command line or via a fast start failover observer. And then finally, in my section, I'd like to talk about just kind of choosing between these two services for your workload. So we've seen kind of how the services differ at an architectural level. We've seen some new features for those. But I've got a workload, and where does it belong? Well, generally when we talk to customers, we want you to think about fully managed databases first. It's less work for you. It's got that 39% lower total cost of ownership and a lot of the capabilities that we've talked about already. And so we think managed databases are really great for customers, so we always want to start there. But what are my requirements for that? Well, these are going to work for custom and third-party applications that really just kind of use the database as a database. They're not using the extended and advanced features that require installing options as sysdba. They don't require host-level access. And this is going to include things like your own custom applications as well as packaged applications, including things like Oracle PeopleSoft, Oracle Siebel CRM, and JD Edwards. These all run on RDS for Oracle just fine. Of course, as we talked about with versions, an application requirement here is going to be that you're running it on a supported version of Oracle database, and it can work with the patches that we include in our minor versions. And today we support databases up to 64 terabytes, so of course it'll need to be that size or less to support with RDS for Oracle. And then so what do you get when you do that? Well, like we talked about, the physical infrastructure is managed by AWS. You've got fully managed database infrastructure. We're just taking care of all these capabilities for you. And again, you'll get listener-level access, so DBA-level access to the listener. You don't get sys or system. You don't get host-level access. But again, as long as your database applications just use the database like a database, this is really fine for most of our customers. So we still see it very popular for a lot of customers. When do I want to use RDS Custom for Oracle then? Well, it's going to be those custom and third-party applications that have those requirements to treat the database as, use those extended and advanced features of Oracle, things that require installing agents on the host, things that require root or sysdba access. And a good example of that's going to be something like Oracle E-Business Suite, which now we can support with availability of support for both 12.201 or multi-tenant for 19c. Both of those let you run those Oracle E-Business Suite applications. Again, you could support whichever version of Oracle database you want, going all the way back to 12.102. And so, as 19c ends, if you're using RDS Custom for Oracle and you don't want to upgrade, you won't have to upgrade. But with RDS Custom for Oracle today, we do still support up to 64 terabytes of storage. So like RDS for Oracle, size is not going to be a big differentiator here. So again, what's the service experience? The physical infrastructure is still fully managed by AWS. The database infrastructure is mostly managed by RDS. We talked about the shared responsibility model. Some of these things are going to be managed by you. So there's a bit of a trade-off there with some additional management work that you'll do. But the trade-off of that is you get the ability to customize and self-manage your infrastructure. And again, that's something that I think we're going to hear from Anish about, installing additional components on servers and customizing your experience with that. And of course, the SSH access to the host that gives you those capabilities. And then finally, if you can't run in a managed service, if you can't run in RDS Custom for Oracle, you can fall all the way back to running your own databases on EC2, which we saw at the beginning a lot of you are already doing. And this is going to be those custom and legacy and complex applications that just whatever about them is not going to fit in the managed database space. Maybe they require more control and customization of what's going on, and you can't have automation interfering with your database when you don't want it. Of course, you get full choice of database versions. You can essentially run anything you can find a supported operating system for on EC2. I think last I saw, you can only run 64-bit Linux, and so that's going to be something like 11.107 or maybe 10.2 should work. But you can run older database versions, and of course, you have full control over which database versions you want. And you get full control over the instance and volume type. So we provide a choice of instance types. If you want something more general than that, if you want bigger volumes, if you want more than 64 terabytes of storage, that might be a use case for running on EC2. Today that can support up to hundreds of terabytes of storage. So what that service experience is going to look like? Well, again, the infrastructure is managed by AWS, but everything else is you. So you're managing the database infrastructure and all of the operations. So that's kind of a quick run through of RDS for Oracle, RDS Custom for Oracle, new features for each, and then again we've got these two services. So think about how you're going to plan which application goes onto which service. And so my last little poll slide here, if we can again pull up that QR code in the camera or in the AWS Events mobile app. And so I'm curious to know, what are the challenges? What's keeping you away from RDS Oracle? And it sounded like a lot of us were running on Amazon EC2 today. So is it that we don't support big enough or performant enough configurations for you? Is it something that's too restrictive with database features and permissions? Is it a TCO or value prop question for you? Or is it just that you're getting started and don't know enough about the service? I'll give a few seconds for y'all to submit those. While we're doing that, if Manish, I think you can come on up. Let you take over. And so could we see the results for that? Very interesting, a very even mix. So it's kind of all of the above. It's interesting to see that nothing really stands out here. So it's database features and permissions and size and performance, and getting to know the service. So hopefully for those of you who are on the don't know enough about the service bucket, hopefully this has been helpful for you. Let you know that there are things that you can do here. This is hopefully a starting point for you to learn more about the service, and then hopefully hearing from Manish about what Jeffries is doing with the service can provide you some more useful insights there. So I will go ahead and turn it over to you.
Thank you, Michael.
Yes, I'm sorry, I should have mentioned that before. We'll do Q&A at the end. Yeah.
Hello, everyone. Thank you for making time. I know it's 7 p.m., right, just as a start of the session, so it's pretty late, but thank you. This is good. So my name is Mohite. I run the cloud at Jeffries. Automation, RDS Custom, Steve Sonnenberg, and Sanjay Kansara. So thank you, Steve and Sanjay. So today, what we want to talk about is who's Jeffries first, right? Why we decided to leverage RDS Custom Oracle. The reference architecture we have for what we did with RDS Custom Oracle, and then what were some of the challenges we ran into, right? And what sort of the conclusion takeaways in terms of our experience there. So starting with Jeffries. Jeffries is a global financial services organization. We offer a lot of products in financial services, many in investment banking, many in fixed income, equities. Our 2021 bottom line was 7.1 billion net revenues. It was 37% increase from the prior year. So we rank 8th globally in the investment banking product space, and 4th in US in equities and electronic trading. And with the first best international brokerage in both India and Japan. So we're global, we're headquartered in New York City. So about 4,500 or so employees. So why RDS Custom for Jeffries, right? So I think first and foremost, right, we believe in database freedom, right? We want to be able to get to open source databases, PostgreSQL, MySQL, a lot of variations of that. But there will often be times where you actually have to do Oracle and RDS Custom Oracle. It might be necessary in many cases. So in this case, we had a packaged application that required a certain level of access, this DBA access within the database, and it had to be Oracle, right? So, that it was sort of like a key driver for us when it came to RDS for Custom Oracle. Some of the key features that were attractive for us was the license portability, right? We were able to get some of our licenses on-prem port over to the cloud was critical. It has to make a good, sound business case from a cost perspective. The AWS managed provisioning, the shared responsibility model within the database was attractive for us, that AWS is still going to do a lot of work, which we don't have to do as a customer. So that was really attractive. Backups and recoveries often become a real pain in terms of management, which is AWS taking care of that. So that was a big plus. Cloud scale is always helpful, right? When I need more storage, I need bigger instance types, I need to get databases up and running in minutes. Having the cloud scale was always attractive, which is one of the key reasons why AWS is attractive. And then I think the integration, right, opportunities when it comes to standard security tooling. We use a lot of, as a financial services firm, we are under regulations, and we have to have a lot of security and compliance aspects to think about. And having some of those capabilities and freedom to be able to do a lot of those things made things a lot easier, in fact, especially from a process perspective. The root level transparency, was very helpful, because now we are actually able to track things at a much granular level and what's happening. And we're going to talk a little bit more about it. And then, as always, Amazon, driven by a customer request and prioritizing the customer feedbacks and so on. So additional features coming into RDS Custom that was always attractive for us, that we know will happen. So these were some of the key drivers for us to look at RDS Custom for Oracle. So what was our reference architecture like, right? So if you look at this, this is an RDS Custom Oracle, and we can kind of go quickly from left to the right. Starts with IBM Guardium, right? So we have sensitive data in the Oracle databases, and it must be protected, and it has to have compliance and audit requirements satisfied. Currently, we use IBM Guardium, and we use the STAP architecture of IBM Guardium with our current databases, and those offer blocking and redaction and audit and all of those features that we are now able to leverage. So part of the key component in an RDS Custom EC2 that is actually owned within RVPC at this point, we are able to deploy the Guardium agent, right? Some of the other things, I'm sure, is bread and butter, right, when it comes to OEM, right? OEM is critical from an overall monitoring and management standpoint. So OEM agents have been deployed on the EC2 instances. Oracle Unified Directory, right? You have lots of databases. We want to be able to scale to many, many databases, and want to be able to have, a centralized identity management for all of our Oracle identities, right? So the OUD is part of our architecture. Splunk is our SIEM, so that's what we use for security incident event management. We're able to get all of the log data from our servers, from the databases and everywhere else, pushed into Splunk, indexed, and available for audit. CrowdStrike, right? So CrowdStrike is a critical security product that provides, we were able to deploy the Falcon agent on our EC2 instances and get a lot of security metrics around malware protection and so on that we were able to do in this space. Zabbix is more that we use today on a Unix monitoring, right? So as this is really Unix monitoring, and although actually this is where a bit of a shared responsibility. AWS is also monitoring the EC2 instance, but we wanted some additional controls. And our process today is dashboard for Zabbix, with people really looking into all of the instances, all of the servers out there. So it kind of helps in terms of improving the process or aligning to our existing process. So we've deployed some of those agents. Atlassian toolsets is what we use for all of our automation, and that's including Jira and Confluence and Bitbucket and Bamboo and so on. And we were able to leverage all of our existing tooling, part of the RDS Custom Oracle, in terms of storing all of YAML files, all of the automation in Bitbucket, and then using Ansible playbooks and so on. So that DevOps tooling was critical for us. Route 53 and a lot of the other services on the right-hand side is bread and butter, right? Pretty much you need those DNS services, you need the KMS encryption. We use centralized KMS CMKs, customer managed keys. So we were able to do a lot of those, with the RDS Custom, and then Secrets Manager for all of the secrets that are going to come up from a database standpoint. So CloudWatch and Systems Manager and the service catalogs are hypercritical in terms of how we manage our databases and how we provide provisioning and deprovisioning and management support. So at the center of a lot of the automation, which we're going to talk about, is really the service catalog, the systems manager, and the CloudWatch agents and so forth. On to the next slide. So automation, right, it's really important here for us that we had the right level of automation in place. So the way we decided to do the automation was really leverage systems manager documents, for a lot of the automation, and abstract those systems manager documents through service catalog, right? So part of that automation, for example, create RDS instance. Yes, there are direct AWS API calls that you can make to create an RDS instance, but we wanted to have a lot of these other things in place, right? The agents, everything else we talked about earlier. We need to really customize the tagging, for example, on those RDS instances. We don't want to just tag the database. We want to tag the EC2. We want to tag the ENI. We want to tag the EBS that comes with it. We want to tag everything, right, with something more relevant, meaningful for us at Jeffries. So the RDS Custom, I'm just giving a sample, that RDS Custom instance actually does all of that automation for us. So the CEV management was a big part of some of the automation challenges. We have lots of accounts. Most enterprise customers will have lots of accounts in their environment, AWS accounts. And if you really look at CEVs and S3 buckets and all the regions we operate in 6 regions and we have 50 accounts. So that's 300 different CEVs that we would have to manage, which can become a lot, right? So centralizing the custom engine version and managing it from one S3 bucket where our DBAs are really managing the CEVs in one bucket and then be able to leverage it across all the accounts in that particular region was a critical sort of automation challenge we had in that space. Being able to read replicas, custom replicas, promote replicas, be able to make DNS changes and so on. A lot of that capability is something that we had to build. And of course, many of these things are actually part of, I'm sure that RDS Custom would be offering more capabilities over time. But these are some things that we had to do. Service call is an important concept, right, where we want to need help from AWS. We want to provide a privilege access for a short duration, a short-lived privilege access. We want to be able to monitor that, audit that. So a service call automation, that's something we built, with our automation documents is something, again, a challenge we had that we were able to build. So I just want to touch on, say, one of the workflows, right? Like when we say build an automation document for an RDS Custom and make it available through a service catalog, what does that actually mean, right? So what you're seeing here is really a sort of very loosely decoupled steps in identifying and building this workflow, right? So starting with defining what the customer engine version is, right? Create a database. When you create a database, you're obviously going to have to be in a wait state for a period of time. Getting the database instance, getting the instance IDs, running the personalization of the database, right? In terms of the Guardian agents, OEM, OUD, and so on, is the personalization aspects. The EC2 that is going to get spun up with an RDS Custom also needs to be personalized with a lot of our Ansible playbooks, right? With all of the agents that we need to deploy and so on. So there's a personalization aspect for that. And then there was the centralized certificate management as well, because we want to ensure that we do our own PKI, our own certificates are part of the architecture. So this is a sample sort of workflow of how we built the automation documents, right? And similar workflows are in place for pretty much a lot of the other challenges we had, right? So conclusion, I guess, right? I mean, RDS Custom Oracle really did provide us significant value in proposition, especially with these packaged applications that we had to move to the cloud, right? And Jeffries really don't want to be managing the databases. We want to really leverage the managed service wherever possible, right? I think one of the big lessons was that, leverage the automation mode, part of the RDS Custom Oracle. So pause automation when you're doing things, and then re-enable automation in that space, and stay within the support perimeter. Oftentimes, you're changing some things, and then you get off support. So being able to monitor that you are within the support perimeter is an important function, because you could be making changes on the EC2 instances, and you could get out of support. So it's really important that, monitoring that aspect of it, and ideally having automated ways to react to it, right? So lastly, I guess, the key message here is, as we consistently hear that, right? Undifferentiated heavy lifting. Really leverage AWS for all the undifferentiated heavy lifting, and we can focus on things that matter to us the most. So thank you again.